There is a root growing in the ground right now that researchers in oncology laboratories across Japan, China, and the United States keep returning to. Not because it is new, because it is old, older than any of the institutions studying it, older than the civilizations that first carried it across open ocean, older, in its cultivated form, than almost every crop that now dominates the global food supply. The sweet potato has been feeding human beings for at least 8,000 years. It crossed the Pacific before any European navigator charted those waters, a fact that took generations of scientists to accept and that still does not have a fully agreed upon explanation. It survived colonial disruption, the displacement of indigenous agriculture, and the long 20th century process by which nutritional density was quietly traded for shelf life and visual uniformity. And inside it, there are compounds, concentrated, biologically active, found in the deepest pigmented flesh of the varieties that predate industrial selection, compounds that ancient healers in the Andes, in Polynesia, in sub-Saharan Africa used in ways that modern oncology is now, without particular fanfare, beginning to validate. The knowledge was always there, it simply was not located in a building that called itself a laboratory. This is Ancient Food Files. We document what was growing before the systems that replaced it were built, the crops, the compounds, the agricultural traditions that were classified as primitive precisely because they were too effective, too distributed, and too old to be converted into property. Before you continue watching, please check the link I provided in this video's description. That way, you can verify it yourself. If that record belongs somewhere permanent, subscribe, not for growth, for the archive itself. Now, let us go back to where this vine began. The Ipomoea batatas, the sweet potato, originated in the tropical lowlands of Central and South America. The oldest physical evidence of its cultivation, recovered from Peruvian cave sites, dates to approximately 8,000 years before the present. The plant in those specimens was already domesticated, already selected, already the product of generations of human attention. The Quechua-speaking peoples of the Andes called it camar. It was not a secondary crop, it was a primary food, a medicine, and in certain highland traditions, a ritual object. The color of the flesh mattered. Purple-fleshed varieties were grown specifically for ceremonial and medicinal use. Their preparation was distinct from the orange and white varieties eaten daily, the knowledge of which variety to use, and when, and how, was carried by specialists, not written down, because writing was not the medium this civilization used for its most important knowledge. It was spoken, it was practiced, it was demonstrated. Then, somewhere between 1000 and 1200 CE, the exact mechanism is still debated, the sweet potato crossed the Pacific. It arrived in Polynesia, not as a seed carried by wind or current, as a cultivated crop, with a name, Kumara, so close to the Quechua Kumar that the linguistic connection has been used as evidence of deliberate pre-Columbian contact between South America and Polynesia. Someone carried it, someone knew what they were carrying, someone on the other shore knew how to grow it. That crossing represents one of the most extraordinary feats of agricultural knowledge transfer in human history. It has been confirmed by genetic analysis. The sweet potato that arrived in Polynesia was domesticated Ipomoea batatas from South America. It did not drift, it was brought. The sweet potato is a vine. It spreads along the ground, rooting at its nodes, covering soil that other crops leave bare. It grows in poor soil, it tolerates drought. It produces a harvestable crop in conditions that would end the growing season for maize, wheat, or rice. The storage root, what we call the sweet potato, is not a true tuber. It is a swollen lateral root, packed with starches, sugars, carotenoids, anthocyanins, and a class of glycoproteins called sporamins that constitute the majority of the root's total protein content. The sporamins are wound response proteins. The plant produces them when damaged, as a repair and defense mechanism. They are, the research now shows, also among the compounds that cancer biology keeps finding relevant. The purple-fleshed varieties carry anthocyanin concentrations among the highest measured in any food crop. Anthocyanins are pigment compounds. They are also potent antioxidants. In the varieties that were grown for medicinal use in the pre-Columbian Andes, the varieties that were selected over generations for depth of color, not for sweetness or size, those concentrations are substantially higher than in any commercially grown sweet potato available today. The vine does not need to be replanted, it regenerates from its own nodes. It can be grown without irrigation and rainfall patterns that would cause crop failure across most of the modern agricultural system. It was built, by 8,000 years of human selection and millions of years of prior evolution, for exactly the kind of conditions that climate disruption is now producing. When Spanish explorers arrived in the Americas in the late 15th and early 16th centuries, they found the sweet potato growing across an enormous range, from the Peruvian highlands to the Caribbean islands to the river valleys of what is now Mexico. They brought it back to Europe. It preceded the common potato on European tables by several decades. Queen Elizabeth I of England is recorded as having been served sweet potato pies at court. But it was in Africa and Asia where the sweet potato became something more than a curiosity. Portuguese traders carried it to West Africa in the 16th century. It spread across the continent with a speed that reflected not novelty but necessity. In regions where soil was poor and rainfall was unreliable and colonial agricultural policies had disrupted existing food systems, the sweet potato grew where other crops could not. It fed people who had nothing else to grow. In China, where it arrived via the Philippines in the late 16th century, it was adopted by subsistence farmers in precisely the regions that experienced the worst famines of the Ming dynasty's final years. A 1594 document by the Fujian governor Chen Xinlong records the deliberate introduction of sweet potato cultivation as a famine relief measure. It worked. The provinces that adopted it survived years that devastated those that did not. The commercial sweet potato that fills supermarket shelves today is, in most markets, one of 2 or 3 varieties. In the United States, the Beauregard dominates. In Europe, a small number of similar orange-fleshed cultivars account for nearly all sales. They were selected for yield, visual uniformity, and the ability to survive a distribution chain that moves produce thousands of miles before it reaches a consumer. The purple-fleshed varieties, the ones with the highest anthocyanin and spiramen concentrations, the ones that the pre-Columbian medicinal traditions specifically distinguished and cultivated, are not commercially grown at any meaningful scale. They are unmanageable by the standards of industrial agriculture. They do not yield as heavily, they do not present as uniformly, they do not carry the sweet, candy-adjacent flavor profile that the market, having been trained to expect it, now demands. There are over 6,000 documented varieties of sweet potato held in gene banks and research collections worldwide. The number available in any given supermarket is 3, perhaps 4. The distance between those two numbers is not a gap in consumer interest. It is the consequence of a selection process that optimized for everything except the compounds that made the plant medically significant for 8,000 years. The spiramen protein has been studied in cancer biology since the early 2000s. Research published in journals including Carcinogenesis, Food Chemistry, and the Journal of Agricultural and Food Chemistry has documented its activity against colon cancer cell lines, its inhibition of certain tumor-promoting enzymes, and its role in regulating cell cycle arrest in laboratory conditions. The vine is still growing, in gene banks and highland gardens and the smallholder plots of farmers in Uganda and Peru and the Philippines who never stopped growing the old varieties because the old varieties worked. The knowledge was never buried, it was simply located in places that the systems which replaced it did not think to look. The soil does not wait for permission, the root does not require validation. It simply grows, as it has always grown, carrying inside it a chemistry that took 8,000 years of human attention to understand and 50 years of industrial agriculture to nearly lose. If this record belongs somewhere permanent, subscribe to Ancient Food Files. We document what was growing before the systems that replaced it were named, so that the next time someone hands you a root and calls it simple, you will understand exactly how much simplicity was required to make it appear that way.